Now let's look at angle-angle side triangle congruence. Notice the slight change in wording from angle side angle to now angle angle side. So the side is not between the two angles. If two angles and the non-included side of one triangle are congruent with two angles and the non-included side of another triangle, then the triangles are congruent. So if you're looking at this picture, we have angle D and P that are congruent, and we have angle G and T that are congruent. And the side that's congruent is the side that's not in between the two in between the two angles. So with the previous lesson, the side had to be DG and PT directly in between the two angles, but for angle side, it will not be the side in between the angles. So this is known as angle side. So you would be able to conclude that triangle DOG and angle PET are congruent by angle side because they have two angles congruent and the non-included side congruent. Like with all of the other triangle congruencies, if you can prove the two triangles are congruent, then you can prove their corresponding parts are congruent and use CPCTC. So let's look at some pictures and let's see if we can make a decision whether or not these triangles are congruent by angle side. So in figure A, we have two angles that are marked congruent. We've got angle S with angle U, and then angle STR with angle UTR. And although we don't have any sides marked congruent, we do have that reflexive side, that side that's in both of those triangles, so that's RT. So we can say that these two triangles are congruent by angle side because we have two angles and the non-included side. So this would be yes, and we would say triangle SRT is congruent to triangle URT. Remember to watch the order when you are naming the triangles. For figure B, we have angle L and angle N marked congruent. We also have side JK and side KM marked congruent. What we don't have marked congruent that we know will be congruent because we've got that bow tie figure or the vertical angle. So we would be able to make a conclusion that JKN and NKL are going to be congruent. So if we look at how it's marked now, then we can see there are two congruent angles and the non-included sides are also congruent. So these triangles will be congruent by angle side angle. So this would be triangle NJK is congruent with triangle LMK. In figure C, we have two marked congruent sides. So we have PN and CL. And then we also have that PE is parallel to IC. And so what that would mean is that angle NPE would be congruent to LCI because those are corresponding angles. And likewise, we could conclude because NE and LI are parallel, we can also conclude that PNE and CLI are congruent because they're corresponding angles. So if we look at what we have right now, we have two angles, but we have the included side. So this would be angle side angle and not angle side. However, you could conclude that angle E and angle I are congruent by the third angles theorem, and then you could transform this into angle side because now you do have two angles and a non-included side. So at initial glance it looked like angle side angle, but it can be transformed into angle side. So triangle PEN is congruent to triangle CIL. And sometimes there is more than one way to prove that two triangles are congruent. It just depends on the information that's given to you. All right, for example 2, we're trying to figure out that third congruence that we need in order to prove that these two triangles are congruent by angle, angle, side. So let's look at what they gave us. They gave us angle S is congruent to angle C. They also gave us A is congruent to angle U. So we've got our two angles. So now we're going to need a side, and we need to make sure that we do the non-included side. The included side would be SA and CU. So as long as we don't use SA and CU, we're good. So we could use SY is congruent to CE, or we could use that AY is congruent to UE. Either of those pair of sides would work because those are both non-included sides. In this proof, we are told that YZ bisects angle WYX. That is our first given. And if angle WYX is bisected, then we know that angle WYZ is congruent to angle XYZ because that is the definition of a bisector. We are also told that angle YWZ is congruent to angle YXZ. So I'm going to mark that as well. And label that given under reason 3. So now if we're looking at our figure, if there's anything else that we could mark, we could conclude that those third angles are congruent, although we don't need to because that won't help me prove that these two triangles are congruent. But we do know that they share side YZ, so we can state that YZ is congruent to YZ. And now we have two angles and the non-included side marked congruent, so we can conclude that triangle WYZ is congruent to triangle XYZ by angle, angle, side. In our second proof, we are told that angle ABC is congruent to angle CED. So I'm going to go ahead and mark that in the picture and then write that that was given. We're also told that AB is parallel to CE. And the reason we're told that is we look at those parallel lines and that transversal, it is going to create two congruent angles. Angle BAC and angle ECD are going to be congruent because they are corresponding angles. So corresponding angles postulate, I'm not going to be able to fit postulate in there. We'll just put POST. Now if we look at what else we have given, we are also told that C is the midpoint of AD. So write that down. The midpoint of AD. That's our last given. And if C is the midpoint of AD, that means C breaks AD into two congruent segments. So that would be segment AC and segment CD. That is our definition of midpoint. Now finally, if we're looking at how the triangles are marked, we have two pairs of congruent angles and a pair of non-included sides marked congruent. So our triangles ABC and CED are going to be congruent by angle, angle, side congruence. For our last proof, we are told that PR bisects angle QRS. If angle QRS is bisected, that means it's cut in half. So that's going to mean that angle QRP and angle SRP are going to be congruent. So angle QRP is congruent to angle SRP by definition of bisector. We're also told that angle S and angle Q are congruent. And then these two triangles share a side PR. So PR is going to be congruent to PR because of the reflexive property. So if you're looking at what's marked congruent, we have two angles and the non-included side marked congruent. So we can conclude that triangle QRP is congruent to triangle SRP by angle-angle side congruence. And if those two triangles are congruent, then we know their corresponding parts are congruent. So we can conclude that segment PS is congruent to segment PQ because corresponding parts of congruent triangles are congruent, CPCTC.